finding the second derivative, we're going to start just obviously by finding the first derivative the same way we always did. That part is not changing. So the derivative of 1 is what, Adam? 0. So we don't need to write it. Lily, what am I going to do for negative xy? Okay, tell me what to write. Correct. So she did first negative x times derivative of the second plus the second y times the derivative of the first equals, Connor, tell me what the other side should say. Stephen? So then we're going to solve for the first derivative. So we'll get that all by itself. So I'm going to add this one over. So I'll have dy dx minus the x dy dx that's there equals, and I'm also going to add this over to the right, 1 plus y. I'm going to factor out and divide over. I'm going to start crunching steps here, so pay attention. Dy dx is going to equal the 1 plus y that was already on the other side. And then when I factor out that dy dx, there would have been a 1 minus x in parentheses, right? And then we can divide over that 1 minus x. So there's our first derivative. We now need to find our second derivative. So notice the notation. I don't know why this is, but the squared's on the d on the top and on the x on the bottom. So d squared y over dx squared equals. And when I take the derivative of this, I need what, Nathan Zorn? Quotient rule. So start that for me, Haley. Mm-hmm. So it's the bottom times the derivative of the top. What's the derivative of the top? Just dy over dx. Good. Minus, keep going, Winter.
1 plus y. Negative 1.
Very good. All over, bottom squared. Okay, so here's where this gets tricky, can get ugly, sometimes gets nicer. You cannot give the second derivative in terms of the first derivative. Okay? So we can't leave a dy dx in our answer. So what you do is you actually take the first derivative and replace that, which is actually going to be kind of nice here because you have 1 minus x, and then when you replace dy dx with 1 plus y over 1 minus x, you'll get that to cancel. And then your second term, I'll just keep simplifying from here. I'm pretty much a negative with a negative 1 is just like a positive 1. So that's just plus 1 plus y all over 1 minus x squared. So this and this will cancel. So our numerator is either 2 plus 2y, or you could factor out that 2 and have it be 2 parentheses 1 plus y's. All over 1 minus x squared, and parentheses. And that's your second derivative. So there's just that intermediate step of not, your second derivative cannot be in terms of your first derivative. You have to sub it out. Bless you. Questions? Okay. Do you want to try the second one on your own? Yes, Haley. Do it. No, you're fine. Oh, thank you. don't start that third one. Raise your hand if you're done with the second one. Oh, almost everyone. Okay, 1 second. Zach, what'd you get for the second example? Did anybody get anything different? Haley, what'd you get? Anybody get anything different? You all got -4 over y cubed? That's what we got. We'll learn from this. We can play teacher with this. Are you sure no one got anything different? We can play teacher with your paper and get bonus points. Who wants to be selfless? Maria, you're a good girl.
I did too, but I found them.
Anybody else? Okay, so this is excellent. Look at this. 3 bonus points. Anybody else? Okay. I don't know whose this is. It's not very dark. So I'm sorry. But take a moment. Jack.
I would have, I don't know what she did once. I would roughly 2 multiply 2 times y and negative.
Okay, so you would have done that. And that would also work. But we want to... You don't have to do that. Winter?
Not sure.
Zach? Zach, are you playing our game? Zach, can you move to the middle towards Jack?
Yeah.
That way I can actually see you and...
Nice to Jack.
Yeah, you'll have a better angle. Alyssa? Josh? Oh, wait, no, Lily's first.
Oh, what?
Just kidding.
Okay, so she has -4y over y, which should be y squared.
Yep, just carelessly lost the squared there. So -4 over y times 1 over y squared. And so it would be -4 over y cubed. Good? Okay. Nathan, can you send that back to somebody? Please, thank you. Here we go. Take another minute. Lily?
Well, when they divided by 2y, they made it 2y and not 2 over y.
Right. And actually, when I was doing this one, I had to remind myself we're actually dividing by 2y. So even though the 4 divided by 2 becomes 2, this y should still be in the denominator. Okie doke? And then from there, we go on. And here's one more. Stephanie?
They didn't reduce the 4 was too wide. The 2 over wide.
They didn't then, but you don't have to. I mean, they did make their life a little bit more difficult moving forward, but that wasn't necessarily a mistake. Nathan? Z.
I'm not sure.
Adam?
It looks like he didn't, when he got his dy over dx, he could have simplified, but it didn't really matter. So when he multiplied it like the second one, you should get 8 over 2y times negative 4, which he did, but if you simplify, it'd be 4 over y times the negative 4 would be negative 16 over y over 2y squared. And when he like multiplies the, like if you square the 2y it'd be like 4y squared, and then you divide it. Right?
Yes, but I don't think you've actually,
I don't know.
you're telling me what to do. I don't think you've actually found his
I
error.
don't know what he's doing.
Jalen?
Yeah, I can't see it.
Connor?
I ended again.
Maria? Taylor?
Wait, I'm not right. No.
Kendall?
You didn't in the second last
I didn't bring down the 2y squared.
Correct. Correct. He just totally missed. He was working on the top and just lost the denominator completely. So this became 8 over 2y with a negative 4, and here's where he stopped writing down over 2y squared. So he was just simplifying the numerator. This should still be over 2y squared, which would be 4y squared, and then negative 16 over y, keep, change, flip. Then negative 16 and 4 would reduce to negative 4 over y cubed. So he had it. He just dropped the denominator. Who got that? Kendall? Nice job. Okay. The next one. We send that all the way. Oh, he's not all the way anymore. All right. So nice job. Again, these are algebra mistakes. So that's I guess good. We just got to be better at cleaning up. All right, this one, the first derivative starts out fine. We have what first? Alyssa, get us started. Tell me what to write.
It's a product rule, so x squared times 2y dy dx plus y squared times 2x
Equals 0. Good. So when we clean this up and get dy dx all by itself, we're going to add the 2 over. We're going to subtract over the 2xy squared. And we're going to divide off the 2x squared y. I did a lot in one step there, so I'll give you a minute to digest that. One thing that you guys mentioned with, I think it was Zach's paper, it doesn't make it wrong, but it certainly makes your life easier if you clean up your first derivative, just like we did before we were doing implicit. Before you move on to your second derivative, make your first derivative easier. Jack commented on that. Instead of keeping it 2 over y or whatever it was, he wanted to make it 2y to the negative first. That's one way. Also, obviously, reducing the 4 over 2y that Zach had could have just been the 2 over y. This one here, we should reduce first to 1 minus xy squared over x squared y. We can get rid of the 2, the common factor of 2. Now, I don't remember the exact reason why I wrote this, but I said to stay away from the quotient rule because I must have done it that way and it got really, really, really ugly, is my guess. Not that it wouldn't work. So if someone is up for the challenge, go for it, Josh. Go ahead, and this is going to get uglier than the previous two either way. But something about that I hated, and in order to point it out to you, I need someone to try that, and we'll take a look at it. But I wrote myself a note to stay away from the quotient rule. So if I'm staying away from the quotient rule, I need to bring this up to the numerator. So keep my 1 minus xy squared, but bring this x squared y up to the negative first power. Do we follow that? Which I can raise each of these terms to the negative first power. So that would be 1 minus xy squared, and then x to the negative second, y to the negative first. And actually, rather than doing, well, I definitely am not going to do a product rule within a product rule, because if I looked at it as first piece, second piece, that would be a product rule, and then I would have a product rule within the second piece, which I don't want. So I actually am going to distribute this. So I have x to the negative second, y to the negative first, minus, and I can follow some exponent rules here. So x to the first times x to the negative second is going to be what? X to the negative first, adding exponents. And y to the second times y to the negative first will just be y. So I have two product rules still, but I don't have product within a product rule, because that can get ugly. So, second derivative goes. I will start with a product rule here. So first, x to the negative second times the derivative of y to the negative first. So that's going to be negative, so I'll put that out in front, y to the negative second dy dx, plus the second, y to the negative first, times the derivative of the first, which is negative 2x to the negative third. I'm going to put my negative 2 out in front. I'll stop there so we can process that product rule on just the first piece of the polynomial. Good? Any questions? Minus, that's my first product rule, minus my second product rule. So I put my minus in front so I don't have to worry about that. So my first, x to the negative first, times the derivative of the second, dy dx, plus my second, y, times the derivative of x to the negative first is going to be negative x to the negative second. So I'm going to put the negative out in front. That plus is going to go to a minus there. X to the negative second. Okay. I don't dare plug this in right now, because that would be crazy. I'm going to clean this up first a little bit to make me feel better about myself. This is negative 1 over x squared y squared dy dx. Minus 2 over x cubed y. I have to distribute this negative sign, so this will be negative 1 over x dy dx. And then plus y over x squared. Josh, how's it going back there?
It's really hard. Yeah.
The quotient rule?
Yeah, it's so hard.
Okay, yeah. I mean, this isn't easy, but the quotient rule is way worse. All right, because I think you have a lot more complex fractions, right? Obviously, quotient rule.
Bad.
Okay, yeah, don't do it. So at this point, I'm ready to, it's not you know, it's as good as I'm going to get. I'm ready to substitute in dy dx. Now, the version of dy dx that you plug in, you've got literally 1, 2, 3, 4 versions to choose from that all equal dy dx. Which one do you think will be easiest to go here? 1, 2, 3, or 4? 1. I think 1, 2. I don't want to reinsert negative exponents. I just work to kind of get rid of all of that. So I'm going to go with this one. So negative 1 over x squared y squared. Don't worry about anything other than plugging in right now. I didn't do anything other than replace the dy dx's right there. I'm going to multiply this fraction. Now watch what I do here, because I am multiplying a binomial by negative 1. When you multiply a 1 minus xy squared times negative 1, what can you do that will make that just easier? Rather than making it negative 1 plus xy squared.
Can I choose scripture?
Yeah, oh yeah. When you multiply a difference by negative 1, it just flips the order. Yes? So I'm just going to make that xy squared minus 1 over, and my denominator is going to be x to the 4th y cubed. My second one I don't have to touch. Same thing on this next one. I'm technically distributing a negative 1 on the top. So that's going to flip that order. So it'll be xy squared minus 1 over x cubed y plus y over x squared. Anything else we can do here? Kaylin? You can easily get a common denominator. First of all, 2 of them are already common, so if you didn't do it for all of them, you would at least combine these two. But x to the 4th would mean this one needs an x. This one needs an x, which we're going to have to give to both of those terms. This one needs an x squared. So they would all have x to the 4th. And for y's, they all need y to the 3rd. So this one needs a y squared. This one needs a y squared. This one needs a y cubed. All right, so now my denominators are all the same. I could focus on the numerator. So this one doesn't change. Xy squared minus 1. This one is now just minus 2xy squared. This one I have to distribute my xy squared, so that's going to be plus x squared y to the 4th minus xy squared plus x squared y to the 4th, all over common denominator, which I'll rewrite in my final answer. In my numerator, what can I cancel? Xy squared minus xy squared? Yes? These two can combine. So I think I'm about ready to write my final answer. I've got 2x squared y to the 4th minus 2xy squared minus 1, all over my common denominator, which was x to the 4th y cubed. stay away from the quotient rule. I mean, if it's not bad, it's not bad, that's fine, but obviously that one would have gotten crazy.
Yeah.
That's about as ugly as they come.
Are we gonna have one that bad?
No. So, what is this? 6 problems? No. So those are your homeworks. That's it. And also that bonus, if anyone wants to look at 45D from last night.